This will be a video explaining how to do some of the exercises from the 7.2 Aplia assignment that works in conjunction with the other 7.2 Aplia video. So what I think I'll do here at the start is just go through and introduce these 4 new rules that we have to go alongside the ones that we got in 7.1. And I'm going to need to install or enable Flash in my browser. Okay, let's try that again. Starting with constructive dilemma. So constructive dilemma is actually a pretty complicated rule. It kind of looks initially like hypothetical syllogism, where the initial condition is you need to have 2 conditionals, but they need to be connected by a conjunction is the deal here. So constructive dilemma needs 2 conditionals that have a conjunction as their main operator that connects them. That's step 1. Then you need a disjunction that has the antecedents or the first parts of those conditionals as the 2 parts of the disjuncts. So here's the example they give you. If P then Q and if R then S. All right. And if I have P or R, so one or the other or both of these are true, that's the antecedents, well then you can kind of do like a double modus ponens and conclude, well, it's got to be the case then that Q or S. So you get the disjunction of the consequence or second parts of those particular conditionals. So here's a case they give us. I'm looking for a combination of conditionals. This looks real complicated. I'm not so sure about this. But my other option is P or Q, and that's not a conditional, that's a disjunction of conditionals. So the only place I can apply it is actually at 3 when I add my line here. So now I'm going to have to work with 3. Now I just need to figure out what other line I'm going to use. Maybe I'll hold off on 3 for a second. But I should notice these have as their antecedents 2 additional conditionals. So I need a disjunction of if P then Q or if R then A, and I nicely have that here at 1. So let's change this. Let's do 1 and 3. A. 1 and 3. So I'm using constructive dilemma as my rule. And what that tells me to do is take those 2 conditionals. You get a disjunction of their antecedents. What you get as your output is a disjunction of their consequence. And here, I mean, technically it doesn't actually matter the order, but the program's going to be pretty strict. They want you to put it in the order of left side conditional, that's the left side of your disjunction. So that's the not B part. And right side conditional of the conjunction, I need to use the right side consequent as the right side of my disjunction. So here's what, C. So that nicely lines up with the conclusion I wanted to prove. I'm going to check that and check proof, and I'm done. That's constructive dilemma. Next up, we got simplification. Simplification is actually a pretty easy rule. What it says is if you have a conjunction of 2 parts, you can break that apart. So if P and Q is true, well, also P is true. And also Q is true as well. So the rules they give you here make it look like, okay, all you can pull out is this P, and I think that's how they're going to want you to do it. Always pull out the left side of your conjunction. But really, you can pull out either part, because what a conjunction says is both parts are true together. So what that also means is they're true separately. So you can really pull out either piece. What they want me to get is Y, if Y then O. I've got that here as part of a conjunction. I've also got it here. So the problem here is that it looks like, oh, I could do either of these. The program is only going to let you do when they... Let me rephrase this, or let me clarify this. For purposes of this program, you only get to pull out the left side of the conjunction, even though really you can pull out either side. And let me show you. So if I try to do here at line 4, and note also that for simplification, it's only 1 line. I don't have to have any additional lines. It's just any line where there's a conjunction, I can pull the pieces apart. So let's do simplification. That's the rule here. If I have a conjunction and I pull them apart, I'm simplifying. And imagine I'm like, okay, at 4, I just want to pull out the right side. So if Y, why can't I find Y? There we go. Then O, it's like they're in alphabetical order. Check that, and it's going to be like, no, you can't do that. All right, fine. Program is pretty specific, even though this is really okay. So I really want to use it on 2. So I'm just going to change this to 2, because 2, the left side of my conjunction, is the thing I want. And then it says, oh, that's fine. So note, when you're doing simplification, you can only pull out, for purposes of this program, the left side of your conjunction. But in reality, simplification, you can pull out either side. because a conjunction just says both of the parts are true. All right, let's get the next one. Probably going to be the conjunction rule or something. Yes, it is the conjunction rule. So a conjunction rule works in reverse. It says if you have two things, two lines on your proof, you can add them together with conjunction. You put an and in between them. And it doesn't matter how complicated the pieces are. It's any two lines in your proof, you can just add them together or put them together. I'm not going to say add because that's going to be a problem. I can put them together with conjunction. So what I want is if not, or excuse me, not, it's not the case that O if and only if I and not O. I've got that here and here, so I'm just going to take lines 1 and 3 where I have the not O part and line 3. Note here they don't care about order. These are on different lines. I can put them in any order that I want. So I'm just going to put line 4 first, or excuse me, line 3 first. So that's the not O triple bar I close parentheses, connect with a dot, and not O. Oops. And, 0 is not going to work. There we go. And that's the conjunction rule. When I'm putting two pieces together with conjunction, that's conjunction. Check it. Okay, and check proof. There we go. Remember, always select grade it now after you check that proof, because otherwise it's going to think you didn't actually submit anything. All right, coming up, last rule we get that's new is the addition rule. This is actually a really cool rule, especially later on once we get implication. So addition says you can take any line in your proof. You don't need two lines, it's just one. So note for conjunction, you need two lines that are already in your proof. You can combine them with conjunction. Addition says take any one line and add to it with disjunction anything you want. Like, and I mean anything. So if you had P in your proof, you could add or Q, but you could also instead add P or if Q then X, but not R. Like anything you want, so long as it's a well-formed formula, you can add via addition. And you get to do that because disjunction says if one of the parts is true, the whole thing is true. So as soon as you have one line in your proof already that you know is true, technically you can add anything to it and that disjunction is still going to be true. So addition is just like go nuts if you want to. Add anything that you want. So here I have T or if not X then Y. Note I don't have a conditional or anything here, but I do have, because this is a disjunction and I already have T, I can just add this second part straight up. I don't have to do anything special. Just I'm going to take T, add to it, not X. Then Y. So there we go, and I did that to line 2. Note it's only one line. I did it to with addition. Check it. So addition is a really useful rule if you're proving something that has a disjunction as the main operator in the conclusion. If you can get one piece of that disjunction, you can just add the other part and be done, is the idea there. Because addition allows you to add anything. Okay, so that's the new rules we've got in play now alongside modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism. We add to that constructive dilemma, simplification, conjunction, and addition. So note, this is for simplification and conjunction. This is the first time we're getting conjunction as a main operator to work with. Also, technically, constructive dilemma also has a conjunction as a main operator, combining two conditionals. And the addition rule is also kind of interesting because it's allowing you to build a disjunction where there wasn't one before. All right, let's take a look at one of the more complicated ones, and then I'll do a super complicated one to end. All right. So here they want me to prove not M. So what I'm going to do, like I've been doing in the past, is I'm going to look and see, is not M already in the argument? Well, no, it's not here verbatim, but here's M. And because it's not M, and this is a conditional, I'm thinking if I can get this by itself and get N being false, well, then I can get M to be false via modus tollens. So that at least gives me some kind of strategy to approach. To get to this, I need to get D or S, and then I could use modus ponens potentially to get it there. But there's also maybe a potential here to try to do, no, maybe not. There's no disjunctions by themselves, so I'm not going to worry about disjunctive or constructive dilemma. So right now I'm thinking, let's see if we can't get D or S, which I already see how we're going to get it. Use modus ponens, get this, get N to be false, and then we're going to be off to the races. So, first things first, I want to get this. To get this, I need to get, now that I have the addition rule, I need to get either D or S, and then I can do some work. So I look here at 1, and I notice, there's D. with a conjunction, if I do simplification, I can just pull that D out because simplification allows me to pull out the left side of a conjunction. So let's pull out D from line 1 using simplification. Note now I've got all these additional rules, so it's going to look a little bit intimidating, but don't get too scared by it. With a little practice, this will be as easy as having the initial 4. So now I've got D. Perfect. Because now I can just add or S with addition. D or S. I got that from line 5 using addition. Check it. Cool. All right. Now I have the left side of my conditional. I can use modus ponens to get if m then n. So just showing here what I'm doing. 5 and 6 using modus ponens gets me if m then n. Check it. A. Oh. Whoops. Not 5 and 6. That's dumb in hindsight. Let's do 4 and 6. There we go. Okay. Because 4 is the line with this as the antecedent, so I can use modus ponens. 5 is not a conditional. That's not going to work. Okay. So now we have this. I need to get n false, so I can make m false with modus tollens. So I got to try to find a way to get to n being false. Is there some way I can do that? Yeah, I think so with this. It's going to be kind of goofy to get to, but here's how I'm going to do it. First things first, I'm going to go back to 5 where I have D, add or A, so I can do modus ponens to get this, because I'm already seeing how this is going to work. So let's do D or A at line 5. Note here, this is something maybe I haven't mentioned explicitly before. You can always reuse lines. Any line that's been used in your proof isn't off limits once you use it. You can keep going back to it if you want. So I could use 5 or 10 times if I wanted to, if that's what it took. Because the only line that's not available for use is this one. Any other line you can use more than once because they're always available. Okay, D or A, and that was addition. Check it, we're good. All right, now let's use modus ponens from 3 and 8 to get that other conditional, which is going to make sense in a second why I'm doing this. So if n then W, where are you at, W? There you are. Check it. And okay, what I need to do now, I note, is I'm going to get not W from line 2 using simplification just to pull out the left side of it as a conjunction. Cool. Now, note here, if n then W, but not W, I can use modus tollens to get not n, and then boom, I can use modus tollens here to get not m. So 2 more lines and we're done. Let's do not n from lines 9 and 10 using modus tollens as a rule. Checker. And lastly now, I'm going to take this not n, combine it with 7 that I was trying to get the whole time to get not m. And that comes from 7 and 11 using modus tollens. All right. Check my proof. I'm good. All right, easy peasy. Okay, and it looks like I'm running a little low on my timer here. I get 15 minutes max on these videos. I'm not going to have time to do 9, which is probably the most complicated one, so I'm going to pause this or close this video, and I'm going to put 9 in a separate video.